Hello everyone. During last class, we have discussed regarding consolidation, its mechanism, and some theory related to consolidation. So, in that theory, we have studied that there is a need for measuring consolidation settlement so as to see or to observe how much a soil can bear load and can settle under a certain amount of load. So the main aim of studying consolidation is to learn the settlement of the soil, how the soil is behaving under certain amount of load. So the ultimate consolidation settlement should be measured from consolidation. So mainly there are two types of settlement available. The first one is the immediate settlement and the next one is the time dependent settlement. The immediate settlement occurs as soon as the weight of the superstructure fall on the soil and it does not depend upon the time. As the name suggests, it normally depends upon the type of the soil and the material through which the load is being transferred. That is the footing on the foundation. But the time dependent settlement is the main settlement which should be studied in this chapter. That is the settlement which depends on the time, and this settlement can be divided into settlements due to consolidation, that is primary consolidation, and settlement due to secondary consolidation or creep. Hence, we can divide the total settlement into three parts, that is S equals to SI plus SC plus SS, where SI is the immediate settlement, SC is the consolidation settlement, and SS is the secondary settlement. In this unit, we are going to study the settlement part, which is time dependent. So, each component of the settlement mainly gets its importance from the type of soil. As I have discussed that immediate settlement always depend upon normally for coarse grain soil. Hence, the SI predominates for coarse grain soil. Normally, in fine grain soil such as clay and silt, as we have already discussed, that they have the water retentive property. Hence, time dependent settlement is the major criteria and which governs the settlement for fine grain soil. And in case of organic soil, secondary settlement has a vital role to play. Normally, the consolidation theory is mainly used for prediction of the settlement for in case of primary and secondary consolidation. So let us go through the curve as we have seen in the curve, that is time versus settlement. It can be seen that the total settlement of the soil is given by S equals to SI plus SC plus SS, where the beginning of the topmost portion of the curve where the settlement is occurring in a few amount and the time consuming is also very less. Suppose C, the time consuming for immediate settlement is C. And here the settlement we are getting for initial load application is SI. Next is the time dependent settlement. As we can see, where the time is being achieved, where the time is being increased, a settlement graph is achieved where settlement is decreasing in a non-linear fashion. So, this total settlement after the immediate settlement is over is known as time dependent settlement. Among this time dependent settlement, the dotted lines portion is falling under primary compression or SC or primary settlement, and the second dotted portion falls under secondary compression. Together, they make the total settlement curve. So, how to find out this value of the settlement? Our main concern in this chapter is to find out the settlement for primary consolidation and secondary consolidation. So, how to calculate the settlement? For finding out the settlement, this is the formula for settlement. That is delta H equals to CCH naught divided by 1 plus C naught log 10 P naught plus delta P plus P naught. So this is mainly the settlement or SC, which is time dependent primary settlement. So how we are getting this value? So first of all, for achieving the value of settlement, we must know the value of the compression index, that is CC. What is compression index? So let us recap to the previous class where we have studied the load versus void ratio, that is E log P curve. In E log P curve we have studied that as soon as we are applying the pressure, the void ratio keeps on decreasing, and whenever this load is being removed from the soil, there is an elastic rebound of the soil. So one curve is obtained where load is being provided and soil get compressed, and again when the load is removed, the soil gets rebounded. After that, when recompression is applied, again the void ratio decreases with increasing in the load. This graph, as we have discussed earlier, is known as E log P curve. So how the coefficient of curvature, where the CC is obtained, compression index is obtained. Compression index is obtained from the virgin compression curve, that is the straight line portion of the virgin compression curve can be expressed by the following relationship, which has been expressed by Terzaghi, that is Cc equals to E naught minus E divided by log of P by P naught, where E naught is the initial void ratio corresponding to the initial pressure P naught, and E is the void ratio at the pressure P. So here we are getting the value of the compression index, that is Cc, which is used for finding out the consolidation settlement. The next value of the settlement can also be obtained from this formula, that is delta H equals to mv into delta P into H naught. What is mv? We are going to study in the next section. Again, the value of the compression index can be obtained either from this graph or it can be obtained from some empirical formula. That is, without consolidation test, we can also find out the value of compression index, that is for undisturbed clay of normal sensitivity whose value must be less than not be more than 4. That is Cc equals to 0.009 LL minus 10, where LL is the liquid limit of the soil. And for the remolded clays, the value of the Cc can be 0.007 LL minus 10. That means whenever we don't have any kind of graph or E log P relationship for finding out the value of compression index, we can easily use this formula for finding out the compression index depending upon the type of soil. So for the another formula for settlement, we need the value of mv. So what is mv? Let us go and study. So before reading what is the value of mv, let us go to the value av. What is av? av is known as coefficient of compressibility or coefficient of compression. What is coefficient of compression? It is defined as the decrease in void ratio per unit increase in pressure. That means whenever there is an increase in pressure, there is a decrease in void ratio, and their ratio is indicated by coefficient of compression or coefficient of compressibility. As we can see the equation that AV, it is represented by AV. So AV is equals to minus delta E divided by delta P. Why it is negative? The negative sign mainly indicates the decrease in void ratio with an increase in pressure. It is only indicating the direction, not the amount that void ratio is decreasing with increase in pressure. This is not calculated in magnitude. And this is the value of compression of the soil, and it can be measured in terms of centimeter square per gram. So this is coefficient of compressibility. Next we are coming to coefficient of volume change or coefficient of volume compressibility. This is indicated by mv. What is its definition? Coefficient of volume change or coefficient of volume compressibility is defined as a change in volume of the soil mass per unit of initial volume due to an increase in pressure. That means what will be the change in void ratio with change in pressure in comparison to the initial volume of the sample. From there we can find out the value of mv as mv equals to minus delta E by delta P into 1 by delta P, that is rate of change of void ratio with increase in pressure. Hence we can easily substitute the value of AV as we have got previously here. So we can get that mv equals to AV divided by 1 plus E0, where E0 is the initial void ratio. So from this value of coefficient of volume change, we can derive the formula for settlement of the soil, that is change in volume of the sample, that is delta H by H naught is the change in volume of the sample per unit increase in pressure, that is 1 by delta P. It is given by mv. So here we can easily write that delta H equals to mv into delta P into H naught. So anyway or the other, from the definition of coefficient of volume change, we are easily getting the value of the settlement. So consolidation settlement or SC can be derived either by coefficient of compression or coefficient of volume change or from the compression index. We can use any of the formula depending upon the type of problem. We can easily find out the value of the SC. So next we are going to study the secondary settlement, that is SS, which is of another important, and SS is mainly occurring due to secondary consolidation of the soil. So how the secondary consolidation soil is occurring? When the excess pore pressure due to consolidation has been dissipated, the change in void ratio continues, but generally very reduced rate. In a very reduced rate it is changing. So this is the phenomena which is known as secondary compression or secondary consolidation. And during this time, highly viscous water between the points of contact, they are being forced out between the grains. So during this secondary consolidation, there is mainly plastic readjustments of soil particle, and the observed secondary consolidation is normally formed, and the progressive fracture of some soil grains takes place. So mainly secondary consolidation, why it is not being considered secondary consolidation? Because it is not governed by the dissipation of excess hydrostatic pressure. The most of the hydrostatic pressure is being dissipated during the primary consolidation only. Hence, Tarzaki theory of one-dimensional consolidation, as we have studied previously, it cannot be applied to find out the rate of secondary consolidation. Hence, this consolidation settlement is not being given such importance, and this value is very much small as compared with the value of the primary consolidation settlement. So how can this be obtained? Normally there is a graph between time and void ratio, and there we can value the secondary compression index. So here we can find out the secondary compression index, and this value is given by C alpha equal to delta H by HF divided by log of T2 by T1. So from this condition of compression index, we can easily find out the value of the secondary settlement. The secondary settlement is given by C alpha into H log of 10 T1 plus delta T by T1, where H is the total thickness of the stratum and HF is the laboratory sample thickness. Delta H is the change in height of the sample from T1 to T2, and T1 and T2 are the time that is elapsed, and T1 is the some time after primary consolidation. So this is the graph for time versus void ratio, where it is shown that with elapsing of time there is a very small increment in the settlement. Hence the value of the secondary settlement is comparatively neglected. Only in case of organic soil this settlement comes into account. Otherwise this settlement is not being considered as important as compared to the primary consolidation. So here we can learn that the main of this settlement, the main governing parameter for settlement is the primary consolidation settlement or